Using compositions of functions, prove the two equations are inverses of one another. The order you do this does not matter. So I'm going to start by going, what is the inverse of x equal to? The inverse of x, start on the inside and work to the outside. The inverse of x is right here. And I'm going to plug it into the outside, which is f. So wherever I see the variable x, I'm substituting it in. So I'm going to write down 1/2, not an x, plus 6. Leave a blank spot there, and I'm going to replace it with 2x minus 12. Distribute the 1/2 through. Half of 2 is 1. Half of negative 12 is negative 6. Make sure to show all of your steps. When you simplify, negative 6 and positive 6 turn into 0, and you're left with 1x. What if you did not get 1x? Problem is done. You have just proved they are not inverses of one another. Okay, I'm going to keep going. Now I start with the inside, which is f of x. What is f of x equal to? And I'm going to substitute it into the variable x in the outside, which is the inverse. So now I'm going to take this and substitute in wherever I see an x. So in the inverse, I have 2 times the quantity, 1/2 x plus 6, subtract 12. 2x minus 12, take out the x and replace it with 1/2 x plus 6. 2 times 1/2, again, 1/2 of 2 is 1. 2 times positive 6 is positive 12. Make sure you show all of your steps. When you simplify 12 and negative 12, simplify to 0, you're left with 1x. And then you write the statement, the two are inverses of one another. Each time you have to get a final answer of x, which is the same as 1x, to prove the two equations are inverses of one another.